Okay, the time has come to start working on actual NFTs. So I prepared another contract that I'm going to share inside the repository. And this contract was originally created by Hashlips, one of my favorite YouTube channels for Web3 development, and I highly recommend you to look him up. He has just amazing repositories and resources in his GitHub, and he's sharing everything for free, and his job is just amazing work. And here also, like, this is a payable NFT minting, and it also has a split with the actual, well, owner of the contract, but also with Hashlips himself. So kudos, man, you've done an amazing job. And if anyone is going to use this contract, I highly recommend to leave it here. It gives 10% to the creator of this contract for each mint. So yeah, we're going to be creating NFTs out of it, and we're going to be minting them. So this contract is importing and inheriting three other contracts, so ownable, counters, and ERC721. I am not going to teach you how to make solidity contracts. It is a complicated process, and this is a fairly simple contract. I've chosen this one because it has a lot of variables and functions that you can update in time, and this will be very useful for future tutorials. So this one will be used multiple times. I'll be doing a lot of tutorials on this single contract for now. However, this contract is minting NFTs in order, so starting with ID 1, 2, 3, and just goes up to a limit of 10,000, which I specified here. I can of course change the limit. I can change the cost of minting. I can change maximum number of mints that you can do per single transaction. I can pretty much change anything. There is an IPFS URI for JSON. So this is for standard that is compatible with OpenSea. But we're not going to publish it on OpenSea just yet until I fill everything in. For now, we're just going to use it to mint just a few very simple NFTs. If you want to mint very specific IDs of NFTs, which could be important to, for example, own a very specific land of tile, not just random JSON information and just random NFT that you normally have in a collection, I will prepare a different example to showcase owning specific plots of land or specific buildings or something that you first explore in game and then you want to purchase through the Web3 interface. But this is just for joining a club. So I called it Unreal Tutorial Secret Club. It has 10,000 NFTs, and anyone who has this NFT will be part of the secret club. So I also flattened the contract, which means that it is already importing all of those imports into the same file. So from 160, it is now 1,350 lines. So it's a bit bigger. But yeah, it's already tested, working. I'm just recompiling, optimization on. Okay, we don't need to publish it anywhere. We just want to actually deploy it directly, but I don't want to deploy it in virtual machine. I want to deploy it through MetaMask, so on actual wallet. And I want to be not on Ethereum, but on Avalanche. No, not on Avalanche. What am I saying? On Polygon. We are testing everything on Polygon right now. But yeah, I could launch this on basically any chain, on Ethereum, Avalanche, Polygon, or even others. But let's use Polygon mainnet. It's cheap, it's easy to use, and I got Matic coins, so it will be fast and simple. We don't need to provide anything. We want to launch simple NFT, lower gas. So we want to use this one, and we are set to go. This should be enough. I know processing time. Yeah, we need to adjust, edit, suggested fees, make it medium. 0.06. Ooh, so like 6 cents to run this contract. Oh, no, wait. Even less than that. Never mind. Okay, so we're doing medium, just a few cents. And we are running this contract, confirm. Yeah, I don't care. Fail to publish. Yeah, I don't care. Okay. So now this should launch the contract. Let's go here. Contract deployed. Okay, great. View on Block Explorer. Yes, please. Let's just copy it. Polygon scan. Polyscan.com. Search for this contract. This contract. Okay, it exists. Awesome. Contract. Verify and publish. Yes, I'm definitely not a robot. I think at least. Yes, I'm not a robot. Great. Oh, awesome. Contract, verify. Compiler, single file solidity, compiler version latest. That's the one I was using, right? 8.17, okay. And MIT license, and yes. And now the entire source code is this. So let's copy it. Paste, optimization, yes. Construction argument, ABI encoded. There was no construction argument because they were hard coded. I didn't specify them, so I leave it empty. Not a robot. Verify and publish. And he should compile the contract and get the same result, and it should be okay. Okay, I go back to contract source. And now I have it confirmed. I'm still not a robot. Okay, verify and publish. Okay, I can go here, and now I have contract, and I have read contract and write to contract. So I can connect to my MetaMask. I am connected with my account, and I can now call those set functions, or I can read contract. So that's great. We got that, and we need just one more thing. We want to go here, and we need to, oh, we don't need it there. We can go here into code, and we need contract ABI, and we're going to need to copy this, and this is going to be useful for calling inside Unreal Engine. So we are now launching our NFT. We have an NFT standard 10K collection, and we're going to use it inside Unreal Engine. Okay, let's jump into Unreal Engine. So now I created this super secret club that we want to enter, and to enter this super secret club we need to have an NFT. So we will need two things. One that is like this door checker that will check if we have NFT, and if we do, those bouncer will let us in. If we don't, we just blocked from entering. And by the way, there's a blocking volume, so you can just jump over this fence. And I could even make like a blocking volume that covers this entire area, and that way you couldn't enter it from anywhere unless you have the NFT, and we might do something like that as well. So we need two actors. One that is checking if we have NFT. Second, that allows us to mint NFT inside the game. So minting NFT will be happening on the owning client. It will not require our server, but checking if we do have an NFT is going to be conducted only on the server side. So yeah, let's begin working with it. So what we need, we want to go into our blockchain library and we want to do, I'm thinking, do we need functions? We actually, okay, let's begin. First of all, we need to decide where do we want to do this general blockchain integration. If we want to do it inside the Pawn, if we want to make it in the UI, where are we going to make it? So when it comes down to minting NFTs, it's going to be happening on the client side. So I think UI is the best place to do it. So we can just go into UI. We have this like color picker or other UIs. We can just create a new one. Widget interface of user widget. Yes, call it UI underscore mint NFT. Okay, and mint NFT will have a panel, just a canvas panel in general, and inside this canvas panel there's going to be a button, and this button is going to be in the middle as usual. 0.5.5, so it's perfectly in the middle. It's going to be 300 by 50, and we need to know if we have an NFT already, and if we don't, we want to mint it. So let's do maybe text. Yeah, it's just a text block. Are we going to change it? Yes, we are. So we're going to go here into graph and we need some variables. We have the button. The button on click is going to do stuff. And we need a variable that is text. So text is of type text. Let's call it button text, and default will be mint, and we can also set here default to be mint, and we can do binding to this text. Okay, so we got this. We can even copy some of the visuals from other UI so it looks more uniform, like this one. We can okay, let's do copy color and opacity, color and opacity, paste. Okay, and same for the button itself. Background color, copy, paste, and now we have same visuals for the buttons. Okay, so we got this mint button. It does nothing else. It has text. Okay, so we need to see when this gets initialized or just refreshed. We need to run a custom event and check if we have NFT. So in order to check if we have NFT, we need to have few variables. We need to have NFT address, which is string. Oh, let's call it contract address. That's better. Contract address, and we need to also create ABI. So let's maybe do begin play. So construct, and we need to ABI. We need to parse ABI from JSON. This is something we need. And the ABI JSON is here. Yeah, cool. Copy contract ABI. Okay. Paste it here. And on success, we want to promote to variable contract ABI. Exactly. So now we have contract ABI and we can check our NFTs based on it. So we need to do an it call. So it call is quite easy. We already did it before, so I'm not going to explain it fully. Get blockchain configuration. Maybe let's do it on construction. And let's promote to variable blockchain config. And we are using Polygon mainnet. So now we can get this variable, and if I change it there, it changes everywhere, and we just need this. And we need from address and to address. To address is the contract address. And by the way, we need to set this value to what we have here. So contract, copy the address and paste it into default. Okay, and it's pure text. So we're doing it call to this address by this URL, and now we need from. So to do from, we're going to refer to the previous tutorial where we created this player state in gameplay. We're going to make a new interface, blueprint interface. I'm going to call it BI, blueprint interface underscore wallet. Let's say wallet. And we're going to have function get user address. Now we can of course generate the address from the local safe store, but we're going to use this as well because we're going to be needing it. And it has just it's a getter, so it just has an output, and the output is address as string. I'm going to show you how to use that. And we need to open our blockchain player state, and we want to implement the address, the interface. So bi underscore wallet, compile, and now we have interfaces, get user address, and we want to just return this client wallet address. So now from any object in the game, as long as we have player state, so we have a player, even on multiplayer, we can get this address. And this is exactly what we're going to do. We're going to get owning player. And owning player is a controller. Get state. And we can get the player state, and now we can get user address as an interface call. So we can now do this, and we have the address, and we can promote this to variable and user address. Okay, so we have the user address. We can use it as from. And we need to, before doing that, we need to create the ABI data. So we got the ABI object. We want to now encode data or encode ABI. Okay, so we want to encode ABI, and we have the ABI as an object, so we can put it here. We can, yeah, this is better. And if this is successful, we want to get the function hash and encoded argument to data and do this it call because it doesn't cost anything. And we want to have latest, so confirmed. We don't want to do pending. We want to see if we have a confirmed minted NFT. Okay. Okay. Okay, and now we need function name. So we go back here and we're going to contract, read contract, and we want to just check balance off. Because all we need to know is that do we have balance off that is greater than 0? So we need to call balance off, and it requires address as an input, so a single input. So balance off, capitalization is important, and we are making an array with a single state here, which is the user address that we just set. So balance off this address, unsuccessful, it call this check. I am checking on this contract for this encoded ABI. When it's successful, response data. You need to decode ABI. No, not here, only here. To decode ABI, you do need the contract ABI object. And you need to put it to data to decode. Function name is exactly the same, so not to make any typos, balance off. And on success, decoded ABI value, we will have a single value. So we just get a copy of the first value. And we want to we want to just print string, just for now, and see how big it is. Let's say 20 seconds. So now on construct, we're doing this, and let's also disable our button for now. So it is visible. I want it to be not enabled. Oh, it's enabled. No. Okay. So it is not enabled. And here, timer by event. I want to set timer by event. The event we are calling is check if we have NFT. NFT check timer. And like I said, the contract already loop, and let's check every 6 seconds if we have NFT or not. So now we'll just display if we have it or not, and we should get a 0, of course, because we don't have it. And if we don't have it and it is 0, I want to enable the button, and if we do have an NFT, I want to disable the button again. Print string, click. Okay. Okay, now I need to call visibility on this widget somewhere. So I probably need a copy of my color vendor, but I need to call him NFT vendor. Okay, and now duplicate is now Control D. Access vendor. Okay. We got this text instead of color vendor to NFT club access vendor, and in event graph okay, show widget, and I just need to change this widget class to mint NFT. I think that's everything. Let's see. So now I will drag this. And I want this little table I made here. And maybe push a little bit forward. Yeah, like here. Okay. So NFT Club Vendor. Let's see. Okay, I go here and nothing happened here. Something happens here. Nothing happened. Okay. Why is that add to player screen? Oh, yeah, I'm testing on multiplayer. Forgot about that. I need to edit both of those vendors to work on multiplayer. Is player controlled and local player controlled? Let's collapse local player. It is the same, so we don't need this, and we can make it pure. And we can also check if it's valid. So if it's valid, then check. If not, then return false. This should fix it. This can stay as is. Okay, B. Show widgets, show widget. Okay, show, do this. Yeah, let's see if it works for the color vendor on dedicated server. It should now without errors. Yes, yes, okay. No errors. Okay, great. So now I just have to do the same here. And I can just copy this. Copy. Know what I'm doing. Function local player paste. Pound pound object reference. Oh, come on. Yeah. So if he is not valid, if he is valid, then you can check this. Oh, that's not even. Great. I love those misclicks. No, I do not want to edit the engine. Thank you. Let's make it not pound but character class. Okay. Pure. Yes. 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 Mint NFT. It's this one. Is it any different than this color picker? How is this being set? This is just default. Okay, color vendor, event graph. Nah, it's fine. Okay. Oh, I didn't connect this because this must be UI underscore NFT. No, how is it called? Mint NFT type. Object reference. Yes, change. Okay, and now both should work on multiplayer that I am testing right now on server. So this works locally and this works as well. Okay, I can still access wallet, I can see my balance. Okay, so I didn't check what it's printing. It should be printing every 6 seconds 0. And we to do first check on init. Yeah, it's saying 0. Great. So let's go back to our, not the vendor, but Mint NFT graph. We want to call this event, check if we have NFT on init, and then on this loop. So now we get this 0. We want to integer. Okay, string to integer. We want to do this. I want to promote the variable NFTs owned. We don't care about which ones, we just care about how many. And we want to print string. I want to make sure that this string data is compatible with integer. So let's see if it properly prints 0 or it will print something different. 0. Just in case 6 seconds 0. Okay, we don't have NFTs. So now if NFTs is greater or equal, no, just greater than 0, we want to take our timer and invalidate it. Clear and invalidate, we don't need it anymore because we have NFTs and we want to take our button and set enabled false. And if it is false, so it is not greater than 0, we want to take this button and set enabled to true. Now we should be testing pending then, not latest, to enable or disable the button. And yeah, now we have checker if we have NFT, if we are proud owner of this club NFT. So now we need to be able to mint this NFT when we click the button. So on clicking the button, let's just make sure that if it goes 0, we have this button enabled. Let's test it. So this should enable immediately the button for minting. Yep, there it is. And I can click it and nothing will happen. Just click, click, click on my client side. So now I need to mint. That's going to be a bit more difficult because for minting, I need to make a transaction. To make a transaction, I need to actually use the wallet. So we're doing what we did before and we need to initialize the wallet in this widget. So we are going to any of those NFTs that required, any of those blueprints that required wallet. And we're going to copy from the init wallet. And we need just this part. Okay. Let's take with the errors. Okay. So first of all, on click, we need to do this. And after this, we need to, create this variable, wallet key. From this wallet key, we need to get the we already can copy this. Public key, generate Ethereum address. I mean, we already have Ethereum address, but let's do it like this. Wait, we have it? I think we have it. User address. Okay, we already fetched the address. Okay. So we just need the private key. Okay, so this is initializing the wallet. Collapse node init wallet. And we just want to say that it is successful. And only if it is successful, we want to continue. So after we initialize the wallet and we have the key and we can do stuff with it, now we need to start working towards making the actual transaction and minting the NFT. So, I need to make this, create wallet, and I need to set default value to wallet. Because this is the save game name that we are using everywhere. So now that we have this, we need to get a number of things. We need to get gas price. And we have the blockchain config, split, get the URL. Okay, on completed successfully, we want to create a variable gas price. That's okay. Here. And once this is completed, we need to get transaction count. Also for this blockchain URL. Address is our user address. And we want to see pending. And on success, we want to generate nonce. Again, not here, but here. And we can now collapse this. Gas price. Nonce, get nonce. So those are async functions. They will be called one after another. And when we have gas price, initialized wallet, and got the nonce, we can now start constructing the actual argument. So we need to encode ABI. And we need to have the ABI object. We need function name, so we are referring here again. And we want to use write contract now, and we want to say mint. and mint have two values. So first of all, it is mint with smaller letters, and it has payable amount and mint amount. Okay, so function name is mint, and we need to make arguments. Payable amount is make string make it value from string with fraction value. Value is 0.05 because this is what I set in Ether, and please make me a value out of it because that's a lot of zeros. So once we make this value, promote to variable value, maybe let's do it like this. It's always good to store it in memory. Get this value, and then we want to encode this value. Okay, so first is payable amount, second is mint amount. So mint amount for us is just 1. We want to mint just 1. I'm wondering, is I'm thinking like this is payable function. Do I really encode payable amount? Now we're gonna see. It might not be even required here. It might be in the call itself. Okay. Once this is encoded successfully, we want to estimate gas price. And we want to again take our blockchain config, split structure pin, put it as URL. From address is our user address, to address is our contract address that we already have here as well. And data is this data, so let's promote it to as data. Let's promote it to a variable, and then let's use it as a variable. Okay, so this is data. Okay, and once this estimate gas price is ready, we have estimate gas, which is promote to variable estimate gas. That's okay. Perfect name. And once we have this, we can sign transaction. And now we can actually do the actual transaction. So it's a lot of steps here. I understand it. Okay, let's collapse those nodes to generate data. And now collapse those nodes to estimate gas. And now wallet key nonce gas price. Gas limit we need to calculate, so that's in a second. To address is the contract address. Value is what we already stored, so value. And data is data. Chain ID comes from blockchain configuration. That's the chain ID. And when this is successful, we have the transaction, signed transaction. Okay, we got the signed transaction. Sign transaction. And after we signed the transaction, we can send the transaction. Send a raw transaction. Okay, so again, config ID is empty, signed transaction data is the signed transaction. And now on success, we want to understand what actually happened, and we want to break this response. I want to do a print string. And we want to print the maybe print text. And we need format text. I'm going to say status success code body. Okay, success, code, and body. I want to know exactly what happened when this finally executed. So collapse nodes, and this is send transaction. So that looks a lot better, but it's still like a lot of work. And oh, gas limit. I forgot. We need to calculate the gas limit. So to calculate gas limit, oh, we have gas limit. In here, estimate gas. It's called estimate gas. So sign transaction. Yeah, the blockchain is telling us how much it will cost, like how much gas and what's the gas price. It's calculating the amount. So this now should be okay. Okay, so this is on click. I want this to happen, and for now, yeah, if it works out, I want to invalidate the button. Why the hell not? And I want to check if we have NFT after clicking this. Okay, this maybe will work. We'll see. So the widget is running on the client, so all the NFT minting is being checked on the client side. It's now only the client will be aware that this even happened. We're going to have a second object that's going to be checking on the server if we have proper NFT. So let's go here. We have this mint button, and let's click it. I have no clue if it worked. It might have not. Okay, let's see what might have happened, and we're going to go through this entire execution. Okay, just so you know, in project settings, you underneath plugins, you have Tree Studio, Blockchain, and you can add those debug things. They're heavy on performance, but it allows you to see everything that is happening in the event log, and it allows you to see live UN 256 values inside the node. So that's going to help me debug everything. Okay, I'm back. Apparently, I had to take a small break to get to the bottom of what was not working in this project. So everything is working as expected. Apparently, when you are calling a function, which is here, the estimate gas function, this is actually on the node executing the function you are checking with the parameters you have provided inside the data. And based on that, he's estimating how much gas you are going to spend on execution of this transaction. So in our estimate gas, we didn't have one value that is going to be added in the version 1.05 that should be online tomorrow, which is simply the transaction value. So I would just take value. I will just have to plug it in into this node. But until that moment, I cannot calculate it, so I just hard coded 66,000 into this estimate gas. Now everything else is exactly as said before. I just copied over some stuff from the wallet so that we see this timer update, and also I added this information. And you can see here I'm just taking NFT owned and printing it here. So I resigned from all the functionality for disabling the button if we already have a ticket. Instead, you can print as many tickets as you want, because I wanted to be able to test this function multiple times over. So how it works now is that I have this character. This is on multiplayer. So I have a verified address on multiplayer, and I can use this verified address now. So if I go here, you can see I already minted 5 tokens. So I got 5 NFTs of the contract that we are working on in this tutorial. And if I hit mint, I got a proper mint, which means that, oh yeah, here you go, 6. So that took just a few seconds, and minting those 6 tokens did cost me quite a lot, because 0.05 is the price of the NFT itself. Anything on top of it is the gas fees, which means that if we took 6, that means we spend 0.3 on the tokens themselves. So you can see that the gas price that we have paid is something really, really small, even for minting NFTs. Yeah. So there's that. Now I can check if I own NFTs or not. I can change my wallet to own none of them, or I can just transfer them to someone else. And we want to use those tokens in the next video to grant access to a designated area that requires those tokens to be in my possessions to access that area. So see you in the next video.